was March. That sentence alone should stop you, because what followed it in California was not what March is supposed to produce anywhere in the western United States, not even in a state that has been redefining its own weather extremes for a decade. It was March, and Palm Springs reached 108 degrees Fahrenheit. It was March, and Burbank hit 98 degrees, shattering a record set in 1997 by 9 full degrees in a single afternoon. It was March, and Phoenix recorded 102 degrees, becoming the earliest in any calendar year that city had ever crossed the century mark. It was March, and 40 million people across Southern California, Arizona, and New Mexico were simultaneously placed under extreme heat warnings, not heat advisories, not heat watches, but the highest alert designation in the National Weather Service toolkit, reserved for conditions that pose a direct and immediate threat to human life. The heat dome that descended on California and the American Southwest in the third week of March 2026 was not a seasonal weather event that arrived slightly ahead of schedule. It was, in the precise language of the scientists who studied it, the most statistically and meteorologically extreme heat event that had occurred in the southwestern United States for as long as rigorous records of extreme heat had been kept. And understanding what it did, how it worked, and what it has set in motion for the summer and years ahead is not optional context for anyone who wants to understand what is happening to the climate of the American West. The atmospheric architecture that produced this emergency has a name that the general public has become increasingly familiar with in recent years: a heat dome. The term describes the behavior of a specific type of high-pressure system, a ridge of heavy, sinking air that anchors itself over a geographic region and refuses to move. As that high-pressure ridge strengthens, it creates a dome of stable atmospheric conditions above the region it covers. Sinking air warms as it descends, compressing and heating through a process called adiabatic warming. The dome simultaneously blocks the weather systems that would normally bring cloud cover, wind, and precipitation to moderate surface temperatures. With the cloud shield gone, the sun's full energy budget, unfiltered, unobstructed, reaches the surface every hour between dawn and late afternoon. The ground heats, the air immediately above the ground heats, and with nowhere for the accumulated thermal energy to go, no fronts breaking through, no cloud cover reflecting incoming radiation, no rain providing evaporative cooling, the temperature climbs day after day, each morning starting from a warmer baseline than the last. Fox 11 meteorologist Maria Quiban described the mechanism precisely during the event. A big dome of high pressure anchored over the southwest, continuing to produce offshore flow, warming up the atmosphere 20 to 30 degrees above normal. That phrase, 20 to 30 degrees above normal, is not hyperbole. The Fox Forecast Center measured the temperature departure from seasonal average during the peak of the event at 35 degrees Fahrenheit, above expected March levels in the most extreme locations. 35 degrees. That is not a warm spell. That is a different season delivered into the wrong month by an atmosphere that has lost the regulatory mechanisms that used to prevent this kind of extreme from occurring. The record-shattering numbers that accumulated across California and the wider Southwest during the event tell the story in the most concrete terms available. Tuesday of the heat wave's peak week alone brought at least 47 new daily temperature records to California and Oregon in a single 24-hour period. By Thursday, the accumulation of broken records had become almost impossible to track comprehensively. Idlewild reached 90 degrees Fahrenheit, not just a daily record, but the all-time hottest day in March that location had ever recorded, breaking the 87-degree record it had set the previous day during the same event. Palmdale hit 91 degrees, breaking a 1997 record. Lancaster reached 93 degrees, breaking the 87-degree record set in 2004. Santa Ana recorded 94 degrees, shattering a 1997 record by 13 degrees. Burbank reached 98 degrees, obliterating a 1997 record that had stood for nearly 3 decades. Palm Springs in the Coachella Valley Desert reached 108 degrees Fahrenheit, a number that the Fox Forecast Center noted would not only be the hottest March day Palm Springs had ever recorded, but would tie the all-time hottest March day ever measured anywhere in the continental United States. Climatologist Brian Brett Schneider's preliminary analysis, published as the event was still unfolding, suggested that March 2026 was on track to beat the previous U.S. national March temperature record, set in 2012 by at least half a degree Fahrenheit. The scale of record breaking was not incremental, it was categorical. These were not temperatures pushing slightly past old marks in the way that a good athletic performance edges a previous best. These were temperatures arriving in a different class from everything the historical record had documented for this time of year. The public health emergency that the heat dome triggered was mobilized across multiple jurisdictions simultaneously, and the response reflected the scale of the threat. The Los Angeles County Office of Emergency Management activated its emergency protocols and began disseminating heat safety guidance and cooling center resources across the county's communications networks. San Francisco's Department of Emergency Management issued public warnings about beach safety, noting that ocean water remained extremely cold despite the air temperature, a specifics, and lethal combination where people seek water to cool down and encounter currents and temperatures that create drowning risk entirely different from what the warm air above would suggest. Cooling centers across Southern California, Arizona, and New Mexico were opened and publicized. Public transit agencies extended service hours to give people without air conditioning additional access to cooled environments. The state of California, which has allocated hundreds of millions of dollars to heat response infrastructure in the years following the catastrophic heat wave of September 2022, a 10-day event that produced a 5% increase in overall deaths, translating to 395 more deaths than expected during that period, deployed those resources as the March 2026 event escalated from warm spell to emergency within days. Dr. David Eisenman of the UCLA Fielding School of Public Health, who has been among the most consistent academic voices on California's heat response inadequacies, noted during the event that despite the funding and the infrastructure, California's response remains organized around emergency management rather than the sustained public health framework that treating heat as a year-round threat requires. Temperatures had topped 100 degrees in March, he observed, and the state was still responding as though heat were a summer emergency rather than a permanent feature of the climate requiring permanent public health infrastructure. The unhoused population of California's major cities faced a specific and acute dimension of the public health emergency that the cooling center announcements and official guidance could not fully address. Physician assistant and researcher Catherine Pocock, who conducts street medicine rounds in Boyle Heights near downtown Los Angeles during heat events, described the frontline reality in terms that no official emergency statement could capture. Walking among people living without shelter during a heat event, she would encounter individuals in altered mental states and face the immediate diagnostic challenge of determining whether the cause was heat stress or substance use, conditions that can present similarly and that require different immediate interventions. What homeless patients need during a heat emergency is simple, she said. Water and ice. Not frameworks, not strategies, not press releases about cooling center locations that require travel and identification to access. Water and ice, delivered to where people already are. The gap between the hundreds of millions of dollars California has committed to heat response infrastructure and the street-level reality of what is actually reaching the most vulnerable people during an emergency event is one of the most consequential failures in the state's public health response to a threat that is now arriving 12 months a year rather than in the summer months alone. The Snowpack catastrophe that the heat dome triggered in the Sierra Nevada and across the wider western mountain ranges represents the second major emergency produced by the March 2026 event, one that will unfold across months and years, rather than the days of the acute heat event itself. Climate scientist Daniel Swain of the California Institute for Water Resources described the snowpack situation in language that left no room for comfort. Every major river basin and state in the West, he said, was experiencing a snow drought. He described snowpack levels as just super-duper alarming, adding that there was really no other way to put it. Colorado's snowpack was already at its lowest level since 1981 due to the preceding warm winter before the March heat wave arrived. In California's Sierra Nevada, where snowfall during the preceding winter had been approximately average, the extraordinary March heat accelerated snowmelt at a rate that the mountains would not normally experience until late May or June. The western United States depends on mountain snowpack as what the Fox Forecast Center described as a natural reservoir, a stored water bank that releases slowly through the spring and early summer, providing a steady flow into rivers, reservoirs, and irrigation systems that communities and agriculture rely on through the dry months. When a March heat dome drains that natural reservoir 4 to 6 weeks ahead of schedule, the water does not disappear. It runs off rapidly, often overwhelming drainage systems and causing localized flooding, before flowing into reservoirs that may not have the storage capacity to capture it all. The water that was supposed to be released gradually through May, June, and July arrives in March and April, and by the time the summer demand peaks, the snowpack that would normally still be providing it is gone. A March 2026 study published in Environmental Research Letters, cited by Swain in his public commentary, confirmed that in years with earlier snowmelt in the West, wildfires generally burned significantly more acres. The heat dome of March 2026 had effectively extended California's 2026 wildfire season by 4 to 6 weeks before April had even arrived. The wildfire risk that the snowpack collapse and early vegetation drying created is the third major emergency strand produced by this single heat event, and it is the one whose consequences will extend furthest into the future. Swain's analysis of soil moisture, which ran near or above average at monitoring stations across the West at the end of March due to the rapid snowmelt soaking into the ground, appeared superficially reassuring until he explained its trajectory. Even though soil moisture was higher than average in late March, he said, it would probably end up being significantly lower than average by mid to late summer. The reason is the acceleration of the drying cycle. Rapid snowmelt deposits water into the soil earlier than usual. That soil water then evaporates and transpires through vegetation earlier than usual, driven by the heat that produced the rapid snowmelt in the first place. By the time the fire season peaks, typically August and September in California, the soils and vegetation that had been briefly moistened by early snowmelt will have completed a full drying cycle and returned to the kind of extreme dryness that produces the conditions for catastrophic wildfire. High elevation forests, Swain specifically noted, were much more likely to dry out significantly later in the summer, precisely the forests that have driven California's most destructive recent wildfires, and that sit above communities whose evacuation routes, emergency services, and infrastructure were not designed for the fire behavior that a warmed and dried landscape produces. The infrastructure consequences of temperatures reaching 108 degrees Fahrenheit in Palm Springs and 98 degrees in Burbank. During a month when those systems were configured for spring operations rather than peak summer demand accumulated rapidly across transportation, energy, and public services simultaneously. California's power grid faced a specific and immediate challenge as air conditioning demand spiked across Southern California to levels that the California Independent System Operator, the entity that manages electricity flow across the state, typically only encounters during August heat events. The grid managed the demand without the rolling blackouts that have plagued California during previous extreme heat events, partly because the March timing meant industrial demand was running at normal spring levels rather than the elevated summer peak that compounds residential cooling demand in July and August. But the grid stress was real and measurable with flex alerts, requests to consumers to voluntarily reduce consumption during peak afternoon hours, issued across the region on multiple days of the heat event. Road surfaces across the Inland Empire, the San Fernando Valley, and the desert communities reached temperatures that caused asphalt softening and required emergency monitoring by Caltrans crews who were not expecting to be conducting summer protocol surface assessments in mid-March. Rail systems across the region imposed speed restrictions on exposed track sections as surface temperatures pushed past the operational safety limits that trigger those restrictions months ahead of when the protocols typically activate. The compounding of infrastructure systems operating simultaneously at the edge of their thermal tolerances, power, transport, water distribution, emergency services, during an event that arrived before the seasonal preparation cycle had been completed, created a system stress test that exposed the gap between what California's infrastructure was designed to manage and what its climate is now capable of delivering without warning in any month of the year. The agricultural economy of California, the largest in the United States and one of the most complex and valuable agricultural systems in the world, faced immediate and compounding losses from the combination of the heat dome itself and the downstream consequences of the accelerated snowmelt it triggered. California's Central Valley, which produces more than a third of the country's vegetables and two-thirds of its fruits and nuts, was experiencing late-stage winter crop stress from the cold and wet conditions of early March before the heat dome arrived. The abrupt transition from cool, wet winter weather to 35-degree above normal heat. The San Joaquin Valley, which require careful temperature management during fruit development stages, faced accelerated maturation that reduces juice content and marketable yield. Wine grape vineyards in Napa and Sonoma, which were beginning bud break, the critical early growth stage when vines are most sensitive to temperature extremes, faced heat damage to early growth that disrupts the vine's seasonal development cycle and reduces the quality of the eventual harvest in ways that are not fully understood until the fruit develops months later. The homeowner insurance crisis that was already redefining California's financial landscape, driven by the catastrophic wildfire seasons of the preceding decade, faced further pressure from the March heat. Event as the actuarial calculations underpinning insurers' risk models were updated to reflect an event that moved the probability estimates for extreme March heat by orders of magnitude. Insurance premiums in high-risk areas were already at levels that were pushing lower-income homeowners out of coverage. The March 2026 heat dome provided further actuarial justification for the trajectory that insurers were already projecting. The World Weather Attribution Organization published its rapid attribution analysis of the March 2026 event on March 20th, 2026, and its findings sit at the center of the scientific understanding of what this heat dome actually represents in the context of climate change. The WWA study combined observation-based data products with climate model outputs, applying the non-stationary extreme value theory framework that has become the standard methodology for attributing extreme weather events to human-induced warming. The findings were unambiguous and striking in their magnitude. Observation-based data showed a strong increase in the likelihood and intensity of heat waves in the region, suggesting that such events have become approximately 4 degrees Celsius warmer as a best estimate compared to a pre-industrial baseline climate. Events as extreme as the March 2026 heat would have been virtually impossible without human-induced climate change, the study found. Combining climate models and observations to account for known model deficiencies in capturing observed warming trends, the WWA estimated an increase in intensity of 2.6 degrees Celsius for such events, with an increase in likelihood of a factor of approximately 800, not 8 times more likely, not 80 times more likely, 800 times more likely. Without climate change, the probability of an event of this magnitude occurring in March in the southwestern United States was so low as to be practically indistinguishable from impossible. With climate change loading the atmospheric dice as it has across the past century of greenhouse gas accumulation, it happened. And it happened in March. The marine heat wave that CNN reported developing off California's coastline in April 2026 traced directly to the same high pressure area that had driven the March land heat wave, added a fourth dimension to the emergency that extends the consequences of the event into the ocean. Climate scientist Dylan Amaya of NOAA's Physical Sciences Laboratory explained the marine mechanism. The high-pressure system that anchored the heat dome over land also created unusually light surface winds off the California coast, which caused marine clouds to be less abundant, allowing ocean water temperatures to spike as they absorbed more of the sun's energy without the atmospheric protection that cloud cover normally provides. You do not get a marine heat wave of this magnitude or spatial extent without some sort of atmospheric driver, Amaya said, identifying the western ridge of high pressure as the culprit. He added that other factors, including broader sea surface temperature patterns, are likely to keep the marine heat wave going for many months to come. The biological consequences of a sustained marine heat wave off California's coast, bleaching of cold water marine ecosystems, disruption of the upwelling systems that bring nutrient-rich cold water to the surface and underpin the Pacific fisheries that support the state's fishing industry, mass mortality events among temperature-sensitive marine species, unfold across a different timescale from the land heat emergency, but are no less real in their economic and ecological consequences. April 2025 to March 2026 was confirmed by NOAA as the hottest 12-month period on record for the continental United States, a finding that places the March 2026 California heat dome not as an isolated aberration, but as the culmination of a full year of record, setting thermal conditions across the country. The broader global context reinforces that framing with a precision that removes any remaining possibility of treating what happened in California as a regional anomaly. Asia in April 2026 was simultaneously experiencing early season heat waves with temperatures peaking at 45.4 degrees Celsius in India and exceeding 43 degrees Celsius in Thailand, driven by the same pattern of intense heat domes anchoring over continental landmasses and delivering temperatures that would have been extraordinary even in peak summer. India, Indonesia, East Asia, all experiencing conditions that previous generations would have classified as once-in-a-century events, arriving in the spring months, driven by the same global atmospheric forcing that produced the California emergency. The Reuters reporting from the start of 2026 documented record heat and raging wildfires rampaging through the southern hemisphere simultaneously, Argentina, Australia, South Africa, with scientists predicting that even more extreme temperatures could lie ahead after 3 consecutive years of globally record-setting annual temperatures. When a single heat dome produces a public health emergency for 40 million people, accelerates a snowpack collapse that sets up a water and wildfire crisis for the entire American West, spawns a marine heat wave with months-long biological consequences for Pacific fisheries and coastal ecosystems, triggers an agricultural emergency across the world's most productive farming state, and is found by the scientific community to have been approximately 800 times more likely to occur because of human-induced climate change, that is not a weather story with a beginning and an end that can be filed away when the temperature drops. That is a climate story whose beginning was decades of accumulated greenhouse gas emissions ago, and whose trajectory does not have a visible end in any current projection. California roasted in March 2026. The question that the science is asking with increasing urgency and decreasing uncertainty is what California, and every other state, every coastal city, every agricultural economy, every water-dependent community sitting on the same accelerating trend line will be managing in March 2036 and March 2046 and every March in between.